Okay, we now do question 9. In this question, we have a picture hanging from a hook with a string, right? So the first thing we do is we draw a free body diagram to identify the forces acting on the picture. The forces would be the force exerted by the string on the picture at the point where the string is connected to the picture, and of course the string is connected to two places. So there are two forces, and of course there's also the weight of the picture frame. Right, so since the frame is in equilibrium, the net vertical force acting on it is 0. Okay, so we need to resolve the vertical forces. We need to resolve the forces in the vertical direction. So let's focus on one of the forces, T. Okay, this force is acting at 45 degrees to the horizontal, so we can resolve this force into a vertical component and a horizontal component, and you can clearly see the right angle triangle here. Okay, we are interested in the vertical component, which is clearly T sine 45 degrees. So we proceed from the previous part. Net vertical force is 0, so T sine 45 is the vertical component, and since there are two such forces which are symmetrical, we will get 2 times T sine 45, and W is in the opposite direction, so it's negative W, and this gives you 0. Alright, so we simplify the problem, the equation, and we find that T is solved to be 3.54 newtons, which is less than the breaking strength of the string, and therefore the string doesn't break. Okay, now we consider the second case. Similarly, we identify the forces acting on the picture frame. Right, I label the two forces exerted by the string as T prime, because now the tension is expected to be different from the first case. W, of course, it doesn't change. Right, so we apply the same reasoning. Since the frame is in equilibrium and vertical force 0, so we resolve the two tensions, T prime, to get T prime sine 5 plus T prime sine 5 minus W is 0. So again, we solve in the same manner, and we get T prime to be 28.7 newtons, which is larger than 25 newtons. So we find that in the second case, the string must be able to withstand a tension of 28.7 newtons for it not to break. Right, since the breaking tension of the string is only 25 newtons, we conclude that the string will break.